Okay, let's start. So thank you for joining us. Welcome. You may know me. My name is Alexandra. I work for the marketing team at Graphware. And today we have Esther Bergmark with us. As always, you may know Esther as well. She's our director of product. Hi, Esther. How are you?
Hello, hi. I'm good. I'm super happy about so many attendees and that we get that webinar started. So
Good.
Yeah, very excited.
And we also have Federica with us. She's a data scientist at Graphware. Hi, Federica.
Hello.
Do you want to tell us what does it mean to be a data scientist in case somebody doesn't know?
Yes, I help our customers to solve problems with graphs and analyze and explore graph data.
Okay, exciting.
Yeah.
Thanks. We're glad to have you here. Okay, so this is our agenda. We'll start with talking about logistics a little bit and why does it matter. We will talk about some challenges of logistics and goals of logistics optimization. And that will bring us to graph technology and Hume and how can you use graph technology and Hume to help you tackle these logistics challenges. And then we will dive into a demo where we will look at how to find the best route for your vehicles. And we will finish with Q&A as always. So use the Q&A tool, ask us questions at any time, and we'll get to all of them, I hope. Okay, are you ready to take it away, Esther?
Well, I am almost ready. Before I started, I wanted to kind of preemptively excuse myself. I might have to step out for a minute or two because I'm waiting for delivery. well, I already got my delivery today. Huge one. I had to run out of another call. The delivery time was obviously not optimized today. Wow. But either way, I won't have to run out now. I wanted to make this stupid little joke because it's kind of a nice bridge to our first poll, right?
Yeah, it is. I'm just pulling it up right now. Because we were wondering how often do you guys order stuff online? Okay. Cool.
We have some results.
Share the results. There you go.
Wow, yeah. It's kind of expected, right? Actually, what I find interesting is this, there's quite a view that say never. Congratulations, you skipped the trend. You can see the trend here, right? We have taken the example here of parcels because it's kind of very relatable, but of course, logistics is a topic that goes far beyond parcels. Our whole globalized economy builds on seamlessly flowing logistics. So it's really important to enable the production of everything we do and our good streams of goods that go around the world, that logistic chains and supply chains are optimized and work, right? The parcel numbers here show a trend that goes through other areas of logistics as well. You see that we picked numbers that, for parcel shipments between 2014 and 2020. And in 2020, we saw 131 billion parcels being shipped, which means 4,160 parcels per second. It's pretty impressive. No wonder if people have to jump out of Zoom calls because it rings on the bell, right? It's of course connected to revenue and well-running business. The total sales in e-commerce mounted up to almost $871 billion in 2021, and the revenue just from parcel shipment amounted to $430 billion in 2020. So, it's an area where focus is well spent, right? If we look a little bit on why logistics optimization is needed, if we look at the goals of logistics optimization, we picked three. Of course, there's more to it, but these three we see them as most representative most logistics companies. And I decided to put customer satisfaction as the first one, because for us at Grapho, it's always the most important goal that we have in everything we do. And I think it's the same for you who joined the webinar today in your business, in your organizations. We want our customers to be happy. And when it comes to deliveries and to logistics, it can be achieved through faster delivery times, of course, right? Through transparency. It's good to, if customers are informed about where shipments are, when they will be delivered, and so on. Sustainability goals. Many logistic companies have very ambitious sustainability goals that they really want to reach. It's genuinely important to really reach them. And the optimization of logistics is one way of doing that. You can plan the shipments, you can plan the delivery routes, you can maximize or optimize how everything works together, and that way reduce your carbon footprint. And last but not least, we list cost savings here, of course, by optimizing the use of resources, and it could be any resource, right? Storage facilities, transportation vehicles, the length of delivery routes, and so on. You save cost. Now, how is all that related to graphs? Oh, I forgot something. My God. So we think that, you have, of course, your goals, but the goals kind of derive from some challenges that you experience, right? So in our next poll, we wanted to ask you what challenges you face in your logistics and supply chain.
Yeah, I'm sorry. I was trying to make this a multiple choice question, but I failed, obviously. So there's just single choice. So just take the most prevalent challenge you're facing, please. Sorry about that.
It's also very interesting for us, right? It's always good to focus down on the one most important thing. Do we have some answers coming in?
Yeah, we just
Oh, some people, maybe it's hard to decide which one of those could be the biggest challenge.
Let's see. Here we are.
Okay, so sustainability didn't get any votes. Interesting. And cost saving is the highest. Very interesting. Okay, delays is also not an issue. Very good. Data management, very through the line, always important. And route optimization, very nice. We're going to cover all that. Good. You're on the right webinar, I can tell you. Okay, so now I couldn't wait for that slide. That's why I jumped so quickly, because it's my favorite one. The great thing is that, graph theory really starts with a logistical problem or logistics problem, let's say. You know that that Leonhard Euler is the father of graph theory. And he lived in Königsberg in the year of 1736. And Königsberg has two rivers, right, or rivers. And there was this kind of riddle between the intellectuals of Königsberg to devise a walk through the city that crosses each of the bridges over the river, but only once. So Leonhard Euler proved that this is impossible. There is no solution to this. And in order to prove that, he needed to, have places and connections between them. So there were the points and the vertices that we still work with today. And today, so many years later, we can build on what Euler found or founded back then, and use graph technology and their capabilities. And we listed 3 capabilities here that we would like to point out. The first one is graph analytics. What we mean with that is that, or graph analytics enable you to represent a problem in a way that enables you to understand it and analyze it. And that sounds like, oh, of course, but it's not so easy, right? If you have a logistic problem, you have sites. You have the site of the warehouse, you have the site of delivery, and you have connections between those sites. So it really needs a graph to represent that correctly. If you have a tabular view, you lose a lot of the power and the capacity. Graphs also enable you to do routes simulation in a very efficient and fast way. You can run several simulations of an algorithm, and in that way obtain the best possible configurations of roads and the deliveries of the orders. Once you have that, you can analyze the routes. So, you don't have to stick with the one that came out on top, but you can feed in fresh data permanently to understand if anything is happening, if anything is changing in the real world that impacts your planned route. And then you can have automated alerts that let you know, and maybe you can tweak and change. We go into that more in detail in a little bit. Good. So at GraphAware, we have Hume as our graph analytics solution. Hume, the wonderful thing with it, there are many wonderful things, but I always start with the fact that it sits on top of Neo4j. It's really built natively onto the graph, which is very different from other solutions that connect to a graph and can visualize a graph database, but Hume is really sitting on top, which makes it much faster and much easier to use. So how we see it is that it's the link between Neo4j as a database and the end user who can then really intuitively work with the graph data and analyze it. That way, Hume helps our customers to solve mission critical questions within a matter of minutes. Often, before Hume, people sit for weeks, for days, things take really long. With Hume, there is no question, it's very fast, and we're going to see that in the demo in a bit. The next thing, and we're also going to see that, is how you can unify data sources. So one of the, we have, like every organization has spent lots of time and effort and money onto collecting data and storing them well. So now we have lots of data in different data sources. There are also new data sources coming all the time. And we need to have one unified view on it to be able to analyze it. And Hume offers that one unified view. Maybe I don't say so much about it now because we're going to see it also in a demo. And I go over to the features. So we looked at graph theory, we looked at graph technology, and then Hume. And now which features in Hume are actually very relevant for logistics optimization? And we listed 9 here. There can be more, but we had to limit ourselves. At some point, we had to draw a line, right? And again, here comes data orchestration again, what I just said. In Hume, you can actually kind of tap into all these data sources that you have and create workflows that help you to orchestrate that data in a stream, right? So you can have, you can stream messages from one component to the other, manipulate the data, and then write it into your Neo4j database and make it available for the person to, that sits with the analysis of the data. Was maybe a bit complex now. Wait for the demo, you see the details. Now imagine you have this stream of data that keeps permanently updated, right? Do you want to sit and look at it manually all the time? Keep track on what's happening? You don't need to do that. We have automated alerts that alert you in case something happens that is of interest for you. So you can define a pattern that is executed against this data. And when the pattern detects an anomaly or a match, you know. Actions. So you have all this data and you want to know things from it, right? You want to query it. Actions in Hume let you send pretty much any type of query towards the Neo4j database. So these are our actions, and we're also going to see them in the demo. When you think about logistics, you might think about a map, right? You might think about things moving in space. So in Hume, you can use the geospatial view to see how goods are moved in space on a map. And then, of course, it's important to have the temporal dimension to it as well, right? So you want to see what happened to a shipment, for example, so far, what happened this morning to this order, to this shipment, to this vehicle. And then once you know that, you might want to take over and see what's happening right now. Where is the transportation vehicle? Where is the order? And that's where the real-time updates come in, where we auto-refresh the data permanently, and you can follow things as they unfold. If you want to do a more like thorough analysis, grouping comes in quite nicely, because what you can do in Hume is that you say, these are attributes I'm interested in. Please group everything that has this attribute, or that where the attribute has this value together. In our example, it's about distance. So you have a certain area where you have deliveries that need to be expedited. And you want to know which of those delivery sites are close by, right? So you can group that. And then there are styles. Similarly, you can say, when these attributes have a certain value, I want the nodes to look in a certain way, or the relationships to look in a certain way. And that helps you to identify patterns without even opening any information about the nodes or the relationships. So you can see it upon the first view, which of course speeds up things and makes the analysis more intuitive. And then I left advanced expand to the end, because it's my personal favorite feature. It's a visual query builder. So you can query the data without using a line of code. You can say, okay, I'm interested in this node, in this class. I'm interested in this relationship types. I'm interested in these values of attributes. You can build your query visually and then run it against the database and see the results. You're going to see it in a bit. So without further ado, I would like to hand over to Federica for the demo, because you're going to see all those things in the demo.
Okay, thank you, Esther. And I'm sharing the screen.
Mm-hmm. And Federica, we should maybe switch off the cameras, right? So we don't take attention from your demo.
Okay.
Yeah, we wanted to give you the full view of the demo. So.
Okay, thank you. I would like to start with the schema of our knowledge graph, so that we can have a clearer idea of the data set that we are analyzing. And as you can see, we have our problem expressed through classes and relationships. We have, for example, orders. Each order is stored in a depot source and has got a destination site. And we have a fleet of vehicles using for goods shipment. We have information about carriers, and lastly, we have actions that are output nodes of our model, containing information on the time a delivery operation takes place, the vehicle it uses, and the order it delivers, and so on. Again, for each class, we have some attributes. For each order, we have a desired, or better, a required delivery date, because we think that it is the most important thing for a customer. Again, we have lots of different constraints, because the problem is very difficult. So, for example, for each depot, we have a time interval that is basically a time window defined by time window start and time window end, in which every operation related to this depot must occur. For each vehicle, again, we have a limited weight capacity that we need to take into account. So this is an overview of the schema. And now let's jump to the visualization, so that we can start our exploration. Suppose that we know that our algorithm, our orchestra workflow that contains the algorithm to dispatch some orders is running. But what we would like to do is to check, to investigate if everything is okay with orders that have a delivery date that is tomorrow, or there is something that we could do manually. For this reason, we can run an action that is basically, as Esther said before, a Cypher, a user-defined Cypher query. And in this case, this is the action we would like to launch. And basically, we are searching for orders that haven't yet been delivered, and that have the required date, that is the date of tomorrow. So let's run these actions that retards a graph we can see here. And it seems that there are 10 orders with that have a delivery date that is tomorrow, we can see here, that haven't yet been dispatched. So we can see that 5 of them are to ARL, but there is something that is that could be particularly useful and interesting, and is the different sides that we have for site nodes. Because we can see, for example, that ARL is a node that is bigger than BER and so on. And this because we defined a style that is here. We can see other details by opening this panel. And we can see that the size of our nodes is based on this attribute, orders attribute. That is the total number of orders that have destination on this site, the total number of orders in the dataset. This means that just by looking at the sites, we can got how important it is for us to ship on time to the site. That is something that could be really useful. And another piece of information is hidden here, because this is the result of a grouping or a clustering operation. Indeed, if we disable this option, we can see that each order has a distinct site destination. But if we enable again, we have a single node that is not a real node, but is a cluster. And in this case, we can investigate the strategy used for this grouping. And we can see that it is based on this attribute, LP closeness. In particular, we have in the same cluster nodes that have the same value of this attribute. And this means that these two sites, are close to each other. But we'll see this better in a few minutes. Now, the question is, can we dispatch these orders that are required by tomorrow? Are we able to do something manually? We can, for example, look for a vehicle that is not busy, for example, seeing if such a vehicle exists, and then try to create a route to dispatch some of these orders. So let's see. I would like to start from an order to ARL, and I want to expand information about the depot in which this order is stored. And at this point, I can launch another action that is basically this query that involves this query, and it searches for orders that are not busy, and in particular for the vehicle that is the nearest to the selected order. And that is because we are sorting based on the distance between the order depot and the location in which our vehicle is. So we can run this action, and we can see that we have a vehicle that is available. But we would like to investigate if this vehicle is really close to the selected order. To do this, we can use another tool that is Advanced Expand. And in this way, we are able to expand some relationships based on both the nodes attributes and relationship attributes. In this case, I wanted to expand this relationship, but I know that the depot in which this vehicle is stored satisfy the condition distance attribute is equals to 0. And so that's it. But I want to show you what happens if we insert another, what happens if we create another condition, if we insert another filter on this node. We can simply ask the algorithm to check if this attribute exists. And in this case, we have both filtering condition that are taken into account. We can expand to graph, and it is true. We have a vehicle that in this case is located in the warehouse in which our order is stored. Now, we want to tell our algorithm that we need to dispatch this order to Al, but maybe I would like to select other orders, and I want to select this one, this other order, and this other. And I just tell my algorithm that we need to schedule this order by adding the label to schedule to these nodes. I run this action, and in the meantime, we have our orchestra workflow that is running. This means that it will read from the database that we have some orders to schedule, and will create a path from all the destination sites. I would like to show you the results in real time, so I will clear the canvas. And I run another action that returns me information about the starting point of this vehicle. Now I can run another action that is basically an auto refresh action. This means that we can follow data changes in real time, and we can follow the results of the simulation in real time, right? So we can see the movement of our vehicles on the map. And we can see that we are going to Troyes, then this other site, this other one, and then Al, and we are turning back to depot. Something that could be interesting is that our solution doesn't take into account the order in which the destinations are selected. Indeed, we selected Al as first destination, but it is the last site that our vehicle visited. And this because the solution calculates the shortest path. Now, what about the solution we defined? It is entirely designed using Cypher queries and Orchestra. That is our graph specialized data orchestration tool. In our case, we just used Orchestra for data ingestion and data manipulation, but it could be much more because it is possible to integrate several sources and externally implemented algorithms and connect them using, for example, an external API. This is something that is possible and easy with Orchestra. Now, about the solution, two are the key points we have reasoned. And the first one is the calculation of shortest path from all the destination starting from the depot, and this to save cost. Another idea is to use the proximity. Let me disable this. Is to use the proximity between destination sites, so as to aggregate sites in a smart way. This is the workflow that we defined for this purpose, and I'm showing you this so that we can have a clearer idea of what a workflow is, an Orchestra workflow is, but at the same time understand the idea of proximity between the sites better. So the first component is a timer that will start the workflow on a specified period, and that we are using a Cypher query component to calculate the distance between the target sites. And this is the query. Then we write on the database the result of the previous action. We create a projected graph and run our clustering algorithm from that is an algorithm from Graph Data Science Neo4j library. And in this case, this algorithm is label propagation. And yes, this is the workflow. But why use a workflow? Easy, because a workflow is fast and it is extremely convenient. because if we want, for example, to change the clustering algorithm, if we want to choose another one, or if we want to change the hyperparameters of the algorithm, we can simply edit the component and rerun again the workflow. Now, let me turn back to the visualization, because I want to run another action so that I can explain you in a better way the solution, and let me disable this option. Okay, here we have 3 different vehicles, 3 different routes. A route for, or a path for each vehicle. This is the first one, this is another one, and lastly the third vehicle and the third route. So here we have the starting point, the depot, that is the starting point of the 3 different vehicles, and then a route. A route is basically a path, is basically a sequence of operations. Each of them is characterized by a date and the time, and has got position information, and this for every operation. We have information about the sites that we are going to visit. We have information about the orders that we are dispatching. We have different information. But basically, we can think to a route as a connection between visited sites. And we can observe that all visited sites for our vehicles, by a vehicle, are in the same cluster. Sorry. Let me run again. Okay. Are in the same cluster. And this because in this way, by aggregating the nearby sites, we assign a vehicle to, let me say, a geographical zone, minimizing in this way costs, because we prevent multiple vehicles going to the same time, or a single vehicle travels much farther to connect the distant sites. If I enable the geospatial analysis, our idea is clearer. It is not the best idea, but it is something that we used to save cost. So if we enable the temporal analysis, we can follow the movement also from a temporal point of view. And we can see the movement of our vehicles as the time goes. So in this case, these are past data, so we can investigate the past vehicles routes. Last thing that is nice to mention, that I wanted to mention, is that we can check results, and more generally, we can monitor changes in data by using Hume's alerts. For example, we can set an alert so that we will be automatically notified if a vehicle returns to depot after the depot closing time, and this is the case. But it is the same, for example, if we want to investigate if a vehicle is broken down or it is delayed, something like this. If some goods are running out of stock, if we are in the supply chain case, what we want. Okay, that's all. This was basically what I wanted to show you, and I think that it's time for questions. So.
Great, thank you, Federica.
Thank you.
We have a couple of questions, so let's start with those. First one is, what kind of data can I ingest to Hume?
What kind of data, you said?
Yeah.
Frederica, is it okay if I take it? So it's it's always bad if you say any, because that sounds as if it's not true, but we really you know, in Hume, there is something that we call the ecosystem, and there we have, there you can connect to resources, and we have, of course, you know, there are all these typical types of resources like file systems or different databases and so on, and you can ingest data from there. Then you could tap into RSS feeds and things like this. So it is really so that you can connect to pretty much any data source and ingest it into Orchestra that we saw in the demo now, and then work with the data there. So you would, you know, you could do entity recognition, entity disambiguation. You can, you know, transform the data in a certain way that you need it to, and then write it to Neo4j.
Right.
So,
Great, thank you. And then the next one is about alerts, actually. So can you just talk about it a little bit more? What kind of events can people be alerted of? What can they keep track of?
I can, if Esther agree with me.
Yeah, please go ahead.
Okay, with the alerts, let me explain better how alerts work. We can basically define some patterns that are queries against the database, so that we explain some conditions, some data that we want to monitor, and we will be automatically notified. We will be automatically alerted if data changes in the database. So, for example, we could insert data about the traffic condition, and in this case, we will be automatically notified if the traffic condition changes, or again, if the vehicle is delayed with respect to the predicted route, the predicted path.
Mm-hmm. Great, thank you. And then we have a question about time zones. How are those dealt with? What happens if a vehicle crosses time zone?
I wonder who said that question. It's always tricky, right? If you work with software and time, and then you come to time zones, it's where it becomes tricky. And we spent actually quite a bit of time figuring it out in Hume. So when we created this time filter that you saw, we had to see, you know, what do we do, because it might be that you are monitoring deliveries that don't happen in your time zone, right? So what if you sit in Central Europe, let's say France or so, and deliveries happen in the UK? It's a 1 hour difference. So what we did is that you can switch time zones, and you can see things that happen in a different time zone, and then see what that means in your own time as well. So we kind of translate, right? When the vehicle goes, let's say they cross the channel to the UK, right? That's a scenario that happens. Of course, then they change time zone, and then you could say, you could change your view on it into the time zone of the vehicle. And then you see their time, and let's say you want to let the customer know when it arrives, you can quote the correct time, right? While at the same time, you could go back to your time, your own time zone, and see it as well. So yeah.
Cool. Great, thank you. I think that's it. We don't have any other questions. So I think that's it. Thank you everybody for coming. Hope you enjoyed it. And thanks guys for a great demo, Federica, and thank you, Esther.
Yeah, thank you. Thank you everybody for joining. It was a pleasure.
Thank you, Alexandra.
Thanks. Have a good day.